Hello everyone, welcome back to my YouTube channel. So into this particular video, we'll be solving 3 or 4 most common SQL interview questions. So these questions are based on some of the medium and advanced level concepts. So you can find the details of all these questions into the description box of this particular video. So if you'll find this video helpful, so don't forget to hit the like button and also subscribe to my channel if you haven't. So let's quickly move to our screen and start solving the problems. So hello everyone, let us start solving the problem. You can see the very first problem onto your screen. The problem says find consecutive available seats. Now we just have 2 columns here into this particular problem. The very first column we have the seat ID, and the second column we have the information whether the particular seat is free or not. So for example, the seat ID is 1, and also you can see 1 means the seat is free and 0 means the particular seat is not free. So you can see onto your screen we have all this information present here. Now for example, what do we want to get from this particular problem? What is exactly the output we want here? So for example, you can see we want to know whether the neighboring seats consecutively definitely means the neighboring seats are free or not. For example, if we go to 1, its neighbor seat, which is the seat ID as 2, it is not free. So into the output, we won't get 1. Now coming to seat ID as 2, so the neighboring seats for seat ID as 2 is 1 as well as 3. So is 1 free? Yes. Is the seat ID 3 free? Yes. So into the output, we'll be getting as 2. Now coming to seat ID as 3. So its neighboring seats will be something like, for 3 the neighboring seat or the consecutive seats are 2 and 4. So is 2 free? The answer is no, it is not free. Similarly, is 4 free? The answer is yes, it is free, but both these seats, the consecutive seats, should be free. So it's not a or condition, it is kind of a and condition. We should have both the seat ID as free here, this particular condition to be successful. Now coming to seat ID as 4. So the neighboring seats are 3 and 5. So whether the the seat ID 4 will be considered into our output? Definitely yes, because 3 is also free and 5 is also free. So into the output we'll also get 3. Now coming to seat ID as 5, there is only one consecutive seat here, which is the seat ID as 4, and whether this is free or not, definitely this is also free. So into the output we'll be getting 5. So into the output we should get somehow, like the logic we should apply, through which we should get into the output 2, 3 and 5, the seat IDs. Let us go to our SQL Server Management Studio, where I have imported exactly the same data set, the small dummy data set here. So what should be the logic, or how should we approach to solve this particular problem? What should be our approach? So the approach may be something like, we have all the seat ID information present here, and I'll just explain you guys how should we go to approach. We'll use 2 things. One will be lag function and one will be lead function. Now what does the lag function give into the output? So the lag function gives the previous row values, and similarly the lead function gives the next row values. So for each row, let us get the next row value into the corresponding row. So if you apply lag here, so you can see there is no previous information present here, so this will be null. For this particular 0, the lag function, so the lag function into the previous row, you can see 1 is present here, so I'll get 1. Similarly here, into the previous row, 0 is present here, I'll get 0. For this, into the previous row, 1 is present at 1. Similarly here, into the previous row, 1 is present here, so I'll get 1. Now lead function is opposite. We'll look into the next row what is present. So for 1, into the next row, 0 is present, so I'll get this. For 0, 1 is present, I'll write here 1. Similarly for 1 is present, 1 is present, and for this there is nothing present, so I'll get here null. So you can see we have to produce, will should produce these two particular columns using the lead and the lag function, and we should apply a particular logic through which we will be getting to know whether the particular seat, consecutive seats are available for a particular seat ID or not. Now you'll see or find a pattern here. So in whichever rows both of these are 1, that mean that the particular seat ID is free. So as you can see, the for this seat ID as 2, both of them are 1. Similarly for seat ID as 4, both of them are 1. So into the output I'll get 2 and 4. Now what about 5? What should be the condition here? So the condition here should be something like, we should have a or condition. So either this particular condition should be true, or either lag should be 1 and lead is null. In that case I'll get 5. Or in many cases, let's say this might be also 1. So in that case also we should get it, seat ID 1 into the output. So just the same opposite logic we should apply for seat ID as 1. We'll implement this into the SQL Server Management Studio, don't worry. Let's go to our SSMS and start writing the query. So first of all, let us get the lag function here. So lag of free over order by seat ID. This lag. Similarly, let us produce the lead function, lead of free over order by seat ID. You can see everything is fine. Let us execute this code. You can see we have got the same output. Now I'll put this into a particular kind of a subquery here. And I'll write select star from, or let's say seat ID from this particular subquery, where LG is equal to 1 and LD is equal to 1. So this was my first condition. The second condition is we should also get the seat ID as 5 into our condition. So we should apply the or condition, or LD is null and LG is 1, or for seat ID is 1. Let us say, what if this ID, for now this is 0, what if we have some particular data set and this is also 1? So we should write where LG is null and LD is 1. That's it. Let us execute this particular code. Okay, this should be equal to, that's it. And you can see into the output we have got our desired result set. And this is how we have solved this particular problem using the lead and the lag function. You can see we have used some advanced level concept, and there was a logic which we had to apply to solve this particular question. Let us move to the second number problem onto our sheet. So the second number problem says, write a SQL query to swap all f and m values, that is change all f values to m and vice versa, with a single update statement and no intermediate temporary tables. Note that you must write a single update statement. Do not write any select statement for this particular problem. Now what is this big question? Like, the statements were quite long, but what actually does this particular question mean? It means that whenever or wherever into the gender column we have m, replace that with a f, and wherever we have a f, replace that with a m using a update statement, just a single update statement. We cannot use a select statement for this. Now what do I recommend here? I would recommend you to pause this particular video, apply spend some time onto this particular problem, because this is a very interesting problem, and just think like how you'll approach to solve this particular problem, and then not able to solve, then again start playing this particular video. Now I'll start solving this particular problem, because this is very much interesting. Now using a single update statement, we need to solve this question. How do we go about solving this? So I have also imported the same data set into our SSMS. I'll just import this right now. So I'll execute this. Let us do a select star from table 2, and you can see I've got the output here. And now into this particular output, we want to apply the particular condition, or to solve this particular problem, we want to change the information. Wherever there is a M, we need to change it to F, and wherever there is a F, we need to change it to M using a single update statement. So how should we go about solving this particular problem? Now this is pretty much interesting. I'll just write here an update statement. So update table 2, set gender is equal to, I'll open a bracket here, I'll use the beautiful case when statement. By the way, I have made a whole detailed video on what is the case when statement from the very basic level to solving some medium level problems, so you can check that particular video out, as the link to that video into the description box also. Now what is the case when statement? These are various conditional expressions which you can provide to solve a particular problem or the SQL problem. Here we will be using the case when statement into the update statement to solve this particular problem. Now how will be applying this? So case when gender is equal to M, then change that to F, else change that to M, and this. I'll execute this particular code. Says 4 rows affected. I'll just select star, and you can see wherever there was a M, we have a F now, and wherever there was a F, we have a M now. So this is how we have solved this particular problem. Now the statement looks quite small, but this was a pretty much interesting information, because you can use the case when statement with the update statement as well. This is a pretty much new information and a pretty much very heavy use case, because you can use this particular information into a lot of more advanced level problems to solve. Let's move to the third number problem. So here the problem says create a pair such that most heavyweight material should go with the lightweight material. Now here we need to create pairs of heavy material, the most heavyweight material, and the most lightweight material. Into the column A, I have the material name or the material IDs. Into the column B, I have the information whether the material is heavy or the material is light. And into the third column, we have the weight of the material. Now we want to arrange or put these materials into pairs of the most heavyweight material as well as the most lightweight material using SQL. So what should be logic through which we should solve this particular problem? So I'll just copy this particular data set. I'll paste this into the side to help you explain what should be the logic. Now let us do one thing. Let us act on the lightweight material and the heavyweight material separately, so that it will be a little bit easier to understand the logic, or what will be the logic which I'll be applying. Now what is the logic? So what is the problem it is saying? So the problem is saying the most weighted material, heavy weighted material should go with the most light weighted material. So we should write a code that should generate output, and into the output we should get answer something like, so the most heavyweight material here is, so I'll just write here output, and into the output, let's just say to the first column we have the heavy material ID, and into the second column we have the light material ID. So into the heavy material ID, you can see which is the most heavyweight material. So the heavyweight material is H4. So I'll just write here H4, So which is the lightest material here present? So this is L4. So this forms a pair. Now coming to the second most highest weight material, so both of them are 54. We can pick any one of them. There is no restriction or there is no constraint present into the particular question. So I'll pick H5, and the second lightest material is definitely L2. Now into the third, similarly third is H1, so H1 should go with L1. I'm just writing the output so that it is pretty much clear when I'm explaining the logic, or what will be the logic which I'll be applying here to solve this particular problem. After H1, which is the 1, so it's H2 and H3. We just have one material left here, which is the L3. So this is something kind of the output which will be requiring into the through our logic. Now how should we go on to proceed this particular problem? So I'll be treating the lightweight material as a separate entity or a separate partition. So basically I'll be using the partition concept here. So lightweight materials for me is a separate partition, and the heavyweight materials for me is a separate partition. I'll provide the rank to all these materials here. And for lightweight materials, I'll be providing the rank onto the basis of the ascending order. So the rank I'll be getting will be something like this. And for heavyweight material, I'll be providing the rank onto the basis of the descending order. So I'll be getting the rank something like this. Now after providing the rank, I'll be joining the lightweight output with heavyweight output onto the basis of the rank column. So one will be joined here. So one rank is H4 will be joined with L4. Let us see, we have the output H4 L4 or not. Definitely we have H4 L4. Now 2 will be joined with 2, so H5 will be joined with L2. That is pretty much correct. Similarly, H1 will be joined with L1, which is also correct. Likewise, both of them should be correct. So this is how we have, or this should be the approach to solve this particular problem. Let us go back to our Excel or the SQL Server Management Studio, where I have imported the same data set. I'll just execute the code here and I'll import the data set here. Okay, so I'll do a select star from L3. Let us execute this. I'll write here select star from table 3, where type is equal to heavy, and I'll write here row number over party. Okay, so no partition is required now. It should be order by weight descending. That's it. Let us rank this. So this query we have created for the heavy materials. Let us create a same query for the lightweight material. I'll remove this descending. I'll put here light. I'll execute this particular code. You can see we have created a separate query for the heavyweight material, and we have created a separate query for the lightweight material here. Now we'll do one thing. We'll join both of these queries. So let us use the results into the subquery. You could have created a temporary table as well. Try creating temporary table, putting both of these results in a temporary table, and then generating the next set of results or next set of logic which I'll be implementing here. But for now I'll be putting this into the subquery here. So what I'll be doing is something like, so I'll just write here A, I'll rate or rename this as B. For me, what is necessary is something like select from A. I want to get the material ID. Similarly, from B, I want to get the material. Let us rename this. So this is a heavy material information. This is a light material information. From this, I'll come to the joining condition afterwards. From this, whatever will be the joining condition, join this on what? So what is the common column on which I'll be joining both of these subqueries? So the common column is the rank column. So I'll just write here rank. Now coming to the joining condition, what do you think? What should be the joining condition which I should be applying here? So let us apply the left join and see what is the output which I'll be getting. You can see, luckily we have got the right output. What if I use the inner join? What will be the output I'll be getting here? You can see we have lost information of the additional row which we had supposed to get, because it is not necessary that we have the same number of materials. The materials can be odd and the number of materials could be even also. So definitely we want the result of the, you know, the odd most material, which is the leftover material for which there was no pairing possible. So I'm using the left join here, and that is why I'm getting the result. What if I swap left with a right join? Do I get the additional row here? Let us execute this. Oh no, we have lost the additional information or the right information which we should have got. So ideally we should use a particular join condition in which we should get the matching result as well as the non-matching result, which is only possible into the full outer join. So instead of right, I should write here full outer join, because I want the matching as well as the not matching record. So I'll execute this particular code, and this is a savior, and you can see we have got the right result after applying the full outer join. There's no, you know, thing which we need to care, because this will give the matching as well as the unmatching record. So friends, this is how this was the particular logic to solve the particular problem. I hope this was pretty much interesting, these 3 questions. Now problem says write a SQL query to rearrange the products table. So we have this particular input, the products table, so that each row has product ID, store and price. So here you can see into the input we have the product ID 01 and the number of quantities which are present into all of these stores. Now we want to rearrange this particular input into the output, which should look something like this. So there are 3 stores and we should get, you know, 3 rows for each of the product, or the information of, you know, simply in simple terms we need to rearrange this particular input into this output. So friends, how do you think, what should be the approach in solving this particular problem? You can see the information we have. Now what is the output we want? So into the output we want the product ID, we have the store. Okay, so I'll just write here select product ID comma, we just write here store 1 as the store. So you can see this, the second column name is store, and I'm just hard coding this as store 1, and into the third column I'll get the information of the store 1 from table 7, and I don't want to have the null value, so I'll just write yes is not null. Let us try executing this statement and if we are able to solve this particular problem or not. So you can see we have the information of the store 1. So we have now assembled the store 1 information into the separate rows. Similar thing we can do for all these stores. So how do we do this for all the other stores? So we can do simply using the union condition, where I'll use the union condition to union all the three stores. So I'll just write here store 2, store 2, store 2, similarly union store 3. Let's execute this particular query to see if we are getting the correct results, and definitely we have got the correct answer, and that exactly was the output which we wanted to have. So friends, this was a kind of easy problem, but the first three problems which we solved were pretty much close to the interview level problem. So these are some of the important questions which you need to solve that will help you to clear your logic, and you will get to know like what are the interviewers they are questioning into the interviews, and how should we approach a particular problem. So that slowly and slowly you will gradually gain the skills and how to apply logics while solving these kind of problems. So do watch my other videos onto the SQL interview question. I'll be bringing much more different videos onto the variety of interview questions, the common interview questions which are being asked into the SQL. Till then, in the next video, thank you so much. Bye.